All right, this is CSE 160, week 6 lecture on reading and writing text files. We discussed some forms of text files in our weekly lecture recorded earlier today, and that lecture exists right here. So let me check on that. Yes, yes indeed. So that's today's synchronous lecture. And so I've added some things. There's today's, we talked about strings. There's today's Python notebook describing that. There's a program here describing dictionaries, a new data type that we described for the first time today. And this Python programming here, 0004A under dictionaries.py, has been integrated into this Python notebook. So if you want to do it in as a Jupyter notebook, I should say, you can do that. This test file.txt and mass mountain data under 0001.csv for comma separated values. Both these files are actually in this folder. So you can go in here and you can download the entire folder onto your machine and use that with today's second lecture here, which is called CSE 160 week-06 under lecture under reading and writing text files, with appropriate dashes. So let's get on to what we want to do here. I'm actually going to do today this particular lecture in PyCharm. Could just as well do it in a Jupyter notebook or in idle, but I just thought I'd do it in PyCharm. And this is a screenshot of when I created this project in Python. The location, now I'm on a Mac, so the location here is /users/JLCooper, my username, /PyCharm projects, CSE 160 week-06 files 0001. And it shows you there's the location there. It also gives you other information in here. And I created a main.py welcome script, which is really not needed, and I will uncheck that on future lectures, future PyCharm projects. It's just not needed. But I wanted to show you how I knew where my PyCharm projects were being built on my machine. If you're in Windows, maybe this says something like C:\users / your username / PyCharm projects, or something like that. But it tells you where things are used, and I needed to know that for the following reason. This is the called Finder on a Mac. It's like Windows Explorer, File Explorer on a Windows machine, and there's a number of files in here that I added. There's my main.py that was created with the project, which I probably won't do that anymore. But I have the various Python programs and everything inside this project. And I also have those Python programs right, in a text editor here, and so we can refer to them that way. Now, that being said, I'm going to close out that screen capture of the project creation page or box, if you will, and I'm going to look at our first program, and I think we can do it in this guy. If our first program is 005 under python-text-files under quadruple0.py, and so I click on that, and here's our file here. I will make this, let's see if I can go in here and preferences, maybe the font can be made larger. I think I've done this before. Use custom font. Apple System UI font size 13. Let's try making it something like 18. And I don't know if that made. I saw something move up here, but it looked. But the font doesn't look any bigger. So let's see here. Maybe we can. It's there's nothing in here to do it. Edit. Nothing under edit. File. File properties. No. Manage IDE settings. No, thank you. New project setup. Save file as template. Oh. Let's just make this huge. I'll go to 26 and I'll say apply. Well, that makes all those windows bigger. And so I think I'll take this back down to whatever it was, 16. Okay. That's great for that, but what I wanted to do is make the font bigger here. And I'm sure there's a way. Here's some settings here. What does that do? Tree appearance, enable preview tab. Well, this is an interesting thing. And then there's this thing over here. Here's something. It says 18 week warnings. Oh. And I don't see that I can do anything. Here's preferences, and we come back to here. Editor. Let's go down to editor. General, font. Okay. And it says size 13, line height, whatever. And so let's just make this bigger. Let's make this like 18. There we go. Hopefully that is more visible, and we can stretch this out. Now, what this does, let's take a look at what we have here. The text files 000 under Python text files, under quadruple0.txt must be in the same directory as this Python program, and we have that file right here. Okay, and if we double click on it, we'll open up. It's a poem by Howard Nemerov from the collected poems of Howard Nemerov. It's entitled Fiction, and it's I've rendered it here in a plain text file. The people in the elevator all face front. They keep still. They all look up with the rapt and stupid look of saints in paintings at the numbers that light up. By turn and turn to tell them where they are. They are doing the dance. They are playing the game. To get here, they have gone by avenue and street, by ordinate, and abscissa, and now by this coordinate up. They are three-dimensional characters taken from real life. They have their fates, whether to rise or fall, and when their numbers come up, they get out. And so, you can find all sorts of meaning in that if you like, but I just thought I'd let you know that's our text file. And it's nothing but printable characters. There's no formatting or anything in there. As I said in my earlier lecture, if you were in Microsoft Word or LibreOffice Writer, which is essentially the same as OpenOffice Writer, or if you were in Macintosh, Pages or whatever they call their thing, you would have formatting. You would probably have, some bolder text and larger fonts and all that stuff, and that would all be encoded in the file. But the file wouldn't contain just printable characters then. And text files, they just contain printable characters. They have no formatting information. So we look at our Python program, and there's some comments up here, and so to access files on the computer, we first have to open the file, in this case for reading. Now, what it means here is that your Python program is running, but it needs a way to say to the computer, there's a file on this computer that I would like to read, say, or write, or do something else with, but it has to tell the computer operating system that. So this open function, this is one of those Python built-in functions that is available to you. And the open function says open, and in quotes there's a file name. This guy right here, and look at this PyCharm as I hover over it, tells me this isn't just 0005 under Python text files under quadruple0.txt. It's /user/JL Cooper /PyCharm project / and then the file name. Well, I'm sorry, the project directory name and then the file name. Okay, so this open command is something that tells the operating system, I would like to access a particular file. And when I hover over open, it tells me it's a built-in, and it gives me information about how that function works. So PyCharm is it's an intelligent integrated development environment, or IDE. So I'm going to open this file, and then there's a comma, and there's another string here of one character for R. It says I'm going to open this for reading, so I'm not going to change it. And this function returns a value which we capture in a variable called myTextFile. MyTextFile is it's a variable, but it contains an object, which is the information. It, contains kind of a handle or pointer or whatever to this file, and allows us to read from it. So the next thing we do is we're going to create a variable called myTextFileLines. And it's equal to myTextFile, that's the file we just opened, myTextFile, .readlines. So .readlines is a method associated with text files, or open files of any kind. And readlines, basically what it does is it makes a list of strings where each list element contains a successive line of the file text. So we should see what we just saw from the poem by Howard Nemeroff. We should see that is now exists in myTextFileLines. And what we're going to do is we're going to do for each line in myTextFileLines. MyTextFileLines is a list of strings. Each string contains a line of the file. We're going to print each line. So we're going to run through that list of lines and print each line. Then we're going to invoke another method associated with an open file, the one called myTextFile. That's the handle or variable that refers to the file I opened, called close. So we opened it, and now we're going to close it. We're telling the operating system we're done. Got no more questions for this guy, right? So we're telling it it's done, and then our program will end. So let's run this thing. And down here, you can see we read in each line of the program, and we printed it. And I think what we did here is we put out an extra new line character. So each of these guys had a new line character. And then when we printed them, we added a new line character. So we can probably fix that. Or maybe looking at one of our other things. Let's try this. Let's take a look at our program now. Now you won't have this. You'll have to do this when you download the program. But we can take here. before we print this line out, I'm going to take this out of here and put it on the next line. And what I'm going to do here is I'm going to say each line, and I'm going to use each line as a string, because each line of the file is held in a string. I'm going to use this string function called strip, and I'm going to strip off. \n is a way to represent new lines. So I'm going to strip off the new lines, okay? And here, let me line up our comments. So I'm going to take each line, I'm going to strip off the new line, and let's see how it prints out when we do that. All right. So let's go up here and run it again. And wait a minute, sorry about that. I think that we had to create a new string here, maybe. Let's see if that does it. I love it when things don't work. So I stripped off the new line from the string because strings are not mutable. So I have to assign it to a, oh gee, I didn't do this right. New each line equals each line dot strip. There we go. Glad I caught that. So we're going to create a new string called new each line is equal to each line, and strip off the new lines, and then we're going to print new each line. Now, this time for sure. So here we go. So as I read in each of these lines, they had a new line at the end of them. I stripped that off, and when I printed it out, the print command prints a line, so it puts a new line back on there. Otherwise, we get the original new line plus the one that the print command puts on, and that's why we had the double spacing previously. So there we go. There's that, and you know, I'm not going to change the file in Moodle. You will have to go modify that. And what we're going to do here, though, is we're going to save this file. Did it save it automatically? I believe it did. And we can test that by going here and let's open that file that we care about. I got to get to the correct directory. Sorry about that. Users JL Cooper. PyCharm projects. Oop, I just loaded the whole bunch, I think. But it doesn't look like the file had been saved yet, because I don't see our changes here. So let's see what I'll take that file. You know, most IDEs allow you to specifically save the file. I don't know if these guys. So if I close this and I open it back up, our changes are in there. I wonder what would happen if I do a Command S, which would be a Control S for you guys. And go in here, and then oh look, it is updated now. See, it says new each line equals each line dot strip. Okay, this is a separate text editor I have right here, and I'm viewing my files from outside of PyCharm, just to give you an idea of what PyCharm is doing. So I hit for you it'd be a Control S if you're in Windows. In Mac it's a Command S. But either that did it, or just over time, every so many minutes, it saves the file. So there we go. We saved that file, and let's close that one. So we've looked at that file. We've looked at that file. Let's look at this next one. This is 0005 under Python text files under 0001.py. And what this does is this is going to open up. Here we're using the open command again, and we're calling this infile. That's our handle, or it's a variable that contains a file object, is what it is. So infile will be our way of accessing the opened file called mass mountain data under 0001.csv for comma separated values. We're opening it in the reading mode. And once again, we're going to do that same thing. I think I always do this when I read text files. Is I invoke the readlines method for the file that's represented by the variable infile. So infile.readlines, and I put in this variable here. This will be a list of strings. Infile lines will be a list of strings. Each string, or each element in this list, will be one line of the file. And then what we're going to do, print for each line in infile lines, print each line. And that's going to, once again, we know what that's going to do. It's going to give us double carriage returns. So let's do our same trick as we did before. Let's come down here and say new each line is equal to each line dot strip \n. Okay, and now instead of printing each line, we're going to print new each line. And so I'm going to do a Control S or Command S, whatever we're going to do. And now I'm going to run this, and what I get here is this one's long, I get each line of this thing, and these are comma separated values. There's the name of a mountain, its height in feet, and its height in meters. And so this goes all the way down here. Here's Mount Williams. It's 2,951 feet, or 899 meters. And this just goes on down. Mount Tom is down here somewhere. Mount Lebanon, Mount Toby. We're shorter than that. Mount Tom is 1,214 feet, or 370 meters, and that's that's the mountain you can see from Granby or from 91 as you're driving north. A distinct mountain has a lot of radio towers on it and that sort of thing. So, right. So let's take a look at that mountain, or at that file if we can. It's right here. Here it is. You can see that it's just lines of text, and the text contains a field of some kind, a comma, a field of some kind, a comma, and a field. So this has three entities in each line, and if I were to open this file, I'm going to close it here. If I were to open that file in so from here, I could do something like, I could open it with, a very common thing would be to open it with Microsoft Excel, or LibreOffice has a thing, or where's Apple, the Numbers app is the default app. But let's try LibreOffice Calc, and it comes up with a little thing and says this is what I'm going to do. And here it is. Let me get rid of the tip thing. This is a spreadsheet, right? And it's just a spreadsheet that contains no formatting information. Like if you could have in a LibreOffice Calc file or Microsoft Excel file or Apple Numbers file, you could have said these are a certain font and these are a certain font and all that sort of thing, and specified the widths of the columns and all that. A .csv file doesn't have any of that. It just has the data. So it's a handy way to pass around data, and you can open that data in a spreadsheet and reformat it locally however you want to. There's our Mount Greylock at 3,491 feet, or 1,064 meters. The only mountain in Massachusetts higher than 1,000 meters. And it's the highest mountain in Massachusetts, obviously. So I'll close that. But that's what a CSV file is. It's a plain text file that spreadsheets can open and work with. But it's a handy kind of text file to be aware of. And so what we did here is we just opened that file and we read it, and we did our old thing where we read in the lines, and we took each line, stripped off the new line, and we printed it, putting on a new line as we printed it, and we got we got this thing to run. So I go back over here and we ran it, and there's our data. That's a CSV file right there that we have read in and then printed out. So that's all well and good. I'm going to close that one. And let's see about some of our other files here. Here, we're going to do something a little more interesting this time. This is very much like 0005 Python text files under 0001.py. We're going to read in that same CSV file, but we're going to print out the mountains that are, what does it say here, greater than or equal to 1,000 feet and less than 2,000 feet. So you need to have this file present, but we already know that because we read it and printed it out without doing anything. So again, in file is a variable containing a file object, and the file object is the object resulting from us asking the operating system to open this file for us for reading. We read in file lines, and then we, by invoking this file object's readLines method, we fill up a new variable called inFileLines with a list of strings, where each string is a line of the file. And then we're going to do some new things here. Although I think we've talked about this split function once before. For each line in inFileLines, excuse me one second, I'm just going to close the door here. There we go. My light switch is a little sensitive. So for each line in inFileLines, we're going to create a list equal to each line dot split comma. So split comma will, as you recall from our last lecture, will take the line, and for instance, let's look at this line here, Gibbs Mountain, 499 feet, 152 meters. It'll turn it into a list. The first element will be the string Gibbs Mountain, the second will be 499, and the third will be 152. Okay? And then we're going to use an if statement. You remember that. In this if statement, we're going to do two things. We're going to say, we're going to convert. Here's each list is our string. I'm sorry, is our list of these three values. We're going to say each list 1, that's going to be the height in feet. Each list 0 is obviously going to be the name of the mountain. Each list 1 is the height in feet. Each list 2 is the height in meters. So we're going to take each list 1 as an integer, okay? And we're going to say, are you greater than or equal to 1,000? And then we wrap parentheses around that. And we're going to say, take the integer of each list 1 and say, is it greater than, or is it less than 2,000? That's why we have parentheses around that. And that's within the parentheses of our if statement. So if each list 1 is greater than or equal to 1,000 and each list 1 is less than 2,000, we're going to print out each list 0, which is the name of the mountain, and its height in feet. And when we're done, we're going to close in file, all right, which is our job to do. So let's run this thing. And what we get, let's go up to the top. The tallest mountain first is less than 2,000 feet. And the mountains get shorter all the way down to Whiting Peak, which is 1,001 feet. And I suspect the next mountain down is certainly not 1,000, because we were looking for greater than or equal to 1,000, so it's probably 900 something. So there we go. We were able to open up this CSV file and pick out the particular mountains we were interested in that were greater than or equal to 1,000 feet in altitude and less than 2,000 feet in altitude. So that being said, we'll close that one. And let's look at this file here. This thing does nothing but create a text file. That shows that we can write things. All right. So let's do out file is equal to open test file dot text. And now we, instead of R, we have W. So we're opening a file for writing. So currently we don't have testfile.text in our project, so we're going to create it, and we're going to use the write method for outfile. Outfile write. There's a string, hello world, and then \n, as we know, is a new line. And then it's going to say, this is our new text file, new line, and this is another line, new line. Why? Because we can new line. Then close the file and print done. All right. So let's again, what are we doing? We're asking the operating system to open a file that we can write to. And in this case, since the file doesn't exist, it'll create the file. And then using that handle or that variable with a file object in it, we're going to invoke the write method and write a series of lines and then close the file and print done. So we run this and we get our done is printed, and notice we have a test file.text up here. When we double click it, it says hello world, this is our new text file and this is another line. Why? Because we can. So now you've seen examples of us reading files and writing files. These are text files, again, plain text files. And we've used the .text extension on the file. That doesn't make it anything. It's more for information. And the .csv. We have one last example here. Let's see if we read and write in the same program. So I'm going to close this one and open our last program here, which is the 0004. And we have an in file and an out file. And this one is going to write a new file. So we're going to open our existing mass mountain data 0001.csv file for reading. And now it may be that someone else would like to have this file, but they need files where the height in meters comes in the second data item, and the height in feet is in the first data item. Or I guess maybe, I'm not sure. Let's see what this does. All right. So first of all, we read in our in file all the lines into a list of strings called in file lines. Then for each line in file lines, we say each line equals each line dot strip. Now that's something we can do. You know, I said strings are immutable, and they are. I can't change the string, but I can take the contents of this string, strip out the new line, and reassign this variable the new string. That's not the same as a string that can't be changed. This is a variable that contains the string. So that sucks as an explanation, doesn't it? I'll tell you what. Even though it works, let's call this new each line, and then we're gonna do everything working on new each line. And if you want to run it the old way, you're welcome to do that and prove that it works. But let's do it this way. It's better documentation. So we're going to create a new line by stripping off the carriage return, right? Then we're going to split new each line here, and well, we've already seen this work, but let's go crazy here. We'll call it newer each line, and now here we have something called each new line equals. Actually, I'm sorry. Never mind. Never mind that last comment. We're creating a new variable. Each list is equal to new each line split. Okay, so what happens is we take new each line, which is a string, find where the commas are, split that into a list of strings, and put it in each list. And now we create something called each new line. This is a variable, and we're going to create a new line, and it's equal to each list 0 plus a comma plus each list 2 plus a comma plus each list 1, and then we're going to print it. That's going to put that new line character in there for us. Print each new line, and then write it to the out file. So you're going to see that we're going to take no, that's not what I want. We're going to take our mass mountain data here. We're going to read in each line, so and then we're going to split it into three things, right? We read in each line, in file lines. I take each line, I get rid of the carriage return at the end. Then I make something called each list, where I split that line into 3 items. So this one would be Mount Greylock, forget the comma, 3491, forget the comma, and 1064. And that would be each list 0, each list 1, and each list 2. Let me say that again. Let's take Mount Prospect. Mount Prospect, after the dot split comma, this will become each line 0. 2690 will become each list sub 1. And this will become each list sub 2. All right. So I go back in here, and what I'm going to do is I'm creating a new line, which I'm calling each new line. I'm saying put the name of the mountain there, and remember, plus can concatenate strings, put them together. We talked about that in today's earlier lecture. Then I'm putting a comma, concatenating each list 2, so the meters is going to be is now going to be the second element in this line. Then I'm putting a comma and each list 1. So this new guy is going to read mountain name, height in meters, height in feet. And maybe we're doing this because, some program we have wants it that way. So then I print them out, so we're going to see them down here in the output box. But I'm also going to write them to the out file. So outfile.write each new line. And then we're going to close the in file and close the out file and see what we got. So let's do this. Let's run this thing and see how we do. Now you'll notice we got a new file up here called Mass Mountain Data. And if I look at this thing, Mount Greylock, now the feet are at the end and the meters are the second item. So I've rearranged my .csv file. And here I've just printed it out. If I want to see the new file, I can double click this and go over here. And it looks like all my data is here. We've got to fix a bug in this. You know what? Mount Greylock. We need to put back in that new line character. I thought the print statement would do it for us, but it did not. So let's go back and put this over here, and let's close this guy because it's wrong. And let's look at this. And I think what we're going to have to do here is we're going to have to add a new line character to the end of this. Okay? And I'll save that. And let's run it again and see how we do. Now down here, oh wait a minute. Yes, down here when we're printing, it we wind up with a I guess a couple of new line characters, and we could do something to to change that. But if we look at our new file up here, now it's great. It says Mount Greylock, and it's got the meters and then the feet. Saddleball Mountain got the meters and then the feet. So in order to have a nice CSV file, we needed that extra. Carriage return there. I guess if we wanted to, we could be fancy. We could do something like this. We could leave it off there. Let's not put it on. Okay. And then that's each new line. Well, why don't we call this one each print new line? And then we'll print each print new line. And then we'll create a new variable here. Each new line is equal to each print new line. And now we'll tack on, and now we'll tack on that that new line character. Save the file. And I will run it again. And notice every time we run it, it will overwrite the existing file. If you open a file for write, you will overwrite the existing data file. And so now when we print it out, it looks nice. And let's close this and reopen it. Make sure it's still good. Yes, when we look at it this way, and can I slide that over? Yes, I can. So there's our original one, Mount Greylock 3491 1064, and here's this one, Mount Greylock 1064 3491. So we did a little bit of fancy fooling around there, and I think the people that watch the video, they get to know about these updates we did, but I'm not going to put those updates into Moodle. Call me a bad person. So that's reading and writing textual files, the most common being the .text, which is a plain text file, and the other one, which is a plain text file which happens to end in .csv, where each line is some values or whatever separated by commas. And so, and they can be opened by spreadsheet programs, and people like using them because they, you know, if you save something with one spreadsheet program, you're not always sure that some other spreadsheet program is going to be friendly enough to open it. But with .csv files, you can know that. There's no formatting, but at least the data is there, and most people care most about the data. The formatting, if they need it, well, then you go through the trouble of having the same spreadsheet program as the creator of that spreadsheet had. So that's that. And we'll say aloha on this video, and I'll post it, and that will end our discussion of files. The next topic we will talk about will be an introduction to JavaScript object notation, or JSON, often called JSON. So JSON is coming up, and that should get us up to date with everything and moving on. And some homework will be posted. I'll be talking with Professor Bigos tomorrow, most likely. All right. Have a great day, and be well, do good work, and stay in touch. Okay? Thank you. Bye.